Hi, good day. This video is all about the one-way Annova for repeated measures. So, by definition of one-way Annova, it is used to determine whether three or more group means are different, where the participants are the same in each group. So, as we can see, we have here our data sheet sample. So, our situation is a teacher want to make a long test for a certain topic. However, he need 20 participants to take the long test 5 times to determine if it will produce a consistent result. So, as we can see, we have here our data sample. We have here the test 1, test 2, test 3, test 4, and test 5. And every test, we can see that it has 20 students in every test. So as we can see, we have here the normality test result. So for test 1, we have here 0.41505, which is normally distributed. So for test 2, we have here 0.35046, meaning this is normally distributed. So for the test 3, we have here 0.20415, meaning this is normally distributed. So for the test 4, we have here 0.18143, which is normally distributed. And lastly, for the test 5, we have here 0.26069, which is normally distributed. So here are the result for the mean. So for the mean for test 1 is 32.6, and the mean for test 2 is 34.85, and the mean for test 3 is 36.75, and the mean for test 4 is 37.9. And lastly, the mean for test 5 is 41.35. Interpretation: test 5 had the highest average and test 1 had the lowest average. So the result, the Annova, the p-value is less than 0.00001. So the interpretation, the hypothesis in null form will be rejected since the computed p-value less than 0.05. Therefore, there is a significance difference in the raw case of each long test. So we have here the narrative discussion. So the objective: is there a significant difference in the raw scores of each long test? So the null hypothesis: there is no significance difference in the raw scores of each long test. Significance: the significance level is equal to 0.05. 1 is equal to 95%. The normality test based on p-value. So for the test 1, we have here 0.41505, which is normally distributed, and test 2 is 0.35046, which is normally distributed. And for the test 3, we have here 0.2415, which is normally distributed. And for the test 4, we have here 18143, which is normally distributed. And for the test 5, we have here the 0.26069, which is normally distributed. So the result, so the mean for test 1 is 32.6, and the mean for test 2 is 34.85, and the mean for test 3 is 36.75, and the mean for test 4 is 37.9. And lastly, the mean for test 5 is 41.35. Interpretation: test 5 had the highest average and the test 1 had the lowest average. the result of Annova, the p-value is less than 0.0007. Interpretation: the hypothesis is in null form will be rejected since the computed p-value is less than 0.05. Therefore, there is a significant difference in the raw is of each long test. So, the data analysis. The given data set had been tested with one-way Annova for repeated measures since each group were consist of some participants or respondents. Each group had been tested with Kolmogorov test for normality with a result of computed p-values such as 0.41505 and 0.35046 and 0.20415, 0.18143, 0.26069 for test 1, 2, 3, 4, 5 respectively. These values suggest that dataset in each group were normally distributed since their computed p-value is greater than 0.05. Descriptive statistic results show that the test 5 had the highest average and the test 1 had the lowest average. On the other hand, testing two datasets with one-way Annova for repeated measures yields to a p-value of less than 0.0001, which is less than a significance level of 0.05. So which means that the computed f value falls under the rejection region. Thus, the decision is to reject the null hypothesis and accept that there is a significant difference in the raw score of each long test. So that's all. Thank you.